and also acceleration. So this is r, this is theta, and there's a radius. If you can remember, we are bothered more about instantaneous center. Now point P will have as no acceleration in this position. Okay, all the information I just gave this one for a given values of a naught r and determine the angle for which it is having a rolling motion. Rolls without slipping. What are the various forces that are, what are the various accelerations that it is possessing? First, a naught, linear acceleration. If acceleration of center of mass is a naught, then all points should also have acceleration of center of mass. All points should also have acceleration of that of center of mass. Then as it is pure rolling, so r alpha. Then it is having v naught, so it will have also angular speed. So therefore we'll get also one more omega naught square r. Under action of all this, the acceleration of point P will be zero, is telling. So if you go for the vector diagram, if you check the advanced paper, we don't have any discussion on these things of this kind. Only instantaneous instant center corresponding to uniform velocity motion is asking. So there's a point on a disk where the acceleration, total acceleration will be zero. Any condition for these two, so it should be 90 degrees. And the way things are given, this is theta. If this is theta, this is theta. This is theta. I think we can go for all this. And this is omega square r. This is linear acceleration. This is tangential acceleration. Determine the angle theta. I think we can just resolve. Very simple problem. Acceleration of point P must be zero. For that, along x and y axis, the resultant acceleration of point P must be zero. Centripetal acceleration, tangential acceleration. This is a linear acceleration. I think this is a thing. So is it now? What about this? Point P on the ground. Linear acceleration, the acceleration along x-axis will be zero. AGX will be zero as it is pure rolling. AGX will be zero. Okay, I agree this. But AGY will be non-zero. Okay. Hope everyone is able to understand, because here centripetal acceleration will be there. This is what we are just applying for pure rolling. I think small ideas can be asked. Anybody, any teacher will try to stress this small basic things. Now A naught is equal to minus omega naught square r cos theta equals 0. Okay, then r alpha sin theta equal to 0. Then along y-axis, omega naught square r sin theta. Okay, solving for theta, we'll get the required answer. Expression for theta is being asked. What is given? A naught, capital R and smaller. So omega has to be replaced. That's what I feel. Omega naught is what we assumed it. What is the given things? A naught, capital R. A naught, capital R, smaller. Omega naught has to be eliminated. So substitute 1 in 2, substitute 2 in 1. So this omega naught you substitute here. Omega naught r square, what you can get? R alpha cos theta by sin theta. Substituting that. R alpha cos theta by sin theta or cos theta. Later on, R alpha, we'll write it as A naught. Okay, this will become A naught cos square theta sin theta, all set equal to 0. So this should become one capital R is missing. Okay, got it. A naught is equal to, in fact, capital R alpha. That I'll change things. Alpha is also unknown, no? A naught alpha will be A naught by capital R cos square theta sin theta R. A naught is equal to R sin theta by R. Cos square theta, R A naught, when you take common, cos square theta plus sin square theta will be 1. Smaller is okay. See this angle theta. Now we can find out. So very good problem. Okay, I'll slide down. Just make observation.
Sir, will not get A naught.
I'll not get A naught. Rama, don't disturb. Oh, A naught will get eliminated, no? There. What do we get then? Sin theta equal to
Small r by capital R.
oh, only that much. Yeah, fine. Sin theta equal to small r by capital. So as you vary smaller, as you change the position of point P, means now you can ask questions. Sir, here only, why can't be here? You do try. In this region, it's possible. So as you vary smaller, that position, that angular position will change. Okay, what about here? This point possible? Not possible, no? Here possible, check it. Only in this fourth quadrant, it is possible. So again, this is a limitation. What is that? The theta, the point P should lie in the fourth quadrant. This is not applicable for this particular thing. I'm making things clear. So don't know, okay, sir, thank you very much. We got this theta, I'll vary theta. No, only here it is possible. You check it here, not possible. Just draw the diagram. Very simple it is. You draw the diagram. Here A naught, R alpha and omega square R. So resultant not possible, no? In different regions, the last one. We'll take one. No, here say that the different parts. I'll show it so that please do remember. So I think we have a very popular way of asking questions in this. Let me summarize everything so it'll be easy for you. So at various points, here A naught, R alpha, omega square R. Here A naught, R alpha. I think that this diagram is what the best diagram what you can remember. Okay, definitely you can see that. I think it's not possible, no? In these regions, acceleration becoming zero, only this region. So this theta is having limitations. The point P has to be located here only. Don't make it generalized. We'll take the next one. I want you to really, it's a very good problem.